In this video, we'll be solving two-step equations. However, you really should not be solving two-step equations until you've mastered how to solve one-step equations. That's because many of the procedures we use for one-step equations are then applied to two-step equations, and it just makes solving two-step equations so much easier when you have solving one-step equations mastered. All right, some things that we're going to keep in mind as we solve these two-step equations are to isolate the variable, use inverse operations, and just a reminder that inverse operations are addition and subtraction, and the other set of inverse operations are multiplication and division. And the third thing, which is even more important now that we have multi-step equations, is that we need to balance the equation for each step, and you need to show that you are balancing the equation for each step. In my first example, I have the equation 3x plus 12 equal 15. My goal is still to isolate my variable x on one side of the equation, but if you notice, I now have two terms on the side of the equation with the variable x. That means I need to do two operations in order to isolate x. So the order that I'm going to do them in is this. I'm going to take care of my constant first, that's step one, and then step two would be to take care of the coefficient. In this example, the constant is 12 and the coefficient is 3. So we're going to take care of getting rid of the 12 from the side of the equation with the variable first. So the opposite of addition, or the inverse operation for addition, is subtraction. So the first thing I'm going to do is subtract 12, and I'm going to do it from both sides because I need to be balanced. Whatever I do to the left side of the equation, I must do to the right side. I'm going to rewrite my equation, and nothing was done to the 3x, but a positive 12 plus a negative 12 is 0. And 15 minus 12, or 15 plus negative 12, is a 3. And I'm just going to simplify my equation as 3x is equal to 3. Now, the next step would be to get rid of the coefficient 3. The operation going on the side of the equation with the variable is multiplication. We undo multiplication with division. And remember again, division in algebra means fractions. I'm going to divide both sides by the coefficient 3, and the 3's on the side of the equation with the x are going to cancel, leaving me with 1x. And 3 divided by 3 is 1. So my solution is x is equal to 1. Now going back and looking at all the different parts of this solution, the first thing I did was to balance my equation by removing 12 from both sides. And then I rewrote my equation so I could see what the next step would be. And then the next thing I did was to balance my equation again before I got to my solution. And students will ask me all the time, why do I need to show you that? Well, you need to show me all the steps, number one, so I can follow along and see if you did it correctly. And number two, it's good process for students to learn how to balance at each step. And to ensure that they're balancing at each step is visually, to visually show that they can do that. In our next example, we have negative 5a minus 17 equal 18. Again, I have two terms on the side of the equation with the variable, so this is a two-step equation. The first thing I'm going to do is take care of the constant that's on the side of the equation with the variable, and then I'll take care of the coefficient. So when I look at my problem, the constant, the operation before the constant, is a subtraction. The inverse of subtraction is addition, so I'm going to add 17 to both sides of my equation. And I'm going to simplify it. Nothing happened to the negative 5a, but a negative 17 plus a positive 17 is 0. and 18 plus 17 is 35. I'm going to rewrite my equation to simplify it. I have negative 5a equal 35. The next step I'm going to take care of is the negative 5a. I'm still trying to isolate that a, and the operation that's going on the side of the equation with the variable is multiplication, and we undo multiplication with division. So I'm going to divide both sides of my equation with a negative 5. My negative 5's cancel out and leave me with an a on the left side of the equation, and 35 divided by negative 5 is a negative 7. So my solution is a is equal to negative 7. Again, I have balanced my equation here. I've simplified my equation here. I've shown I've balanced the equation again here, and then I've come up with the solution a equal negative 7. In my final example, I have the equation 10 is equal to negative 2y plus 22. I'm still going to isolate my variable, and on the side of the equation with my variable, I have two terms. So I'm going to take care of the constant term first, and then the coefficient that is next to the variable. So the first thing I do is look on the side of the equation with the variable. I have addition going on that side of the equation. I undo addition with subtraction. So I subtract 22 from both sides of the equation. 10 minus 22 is a negative 12, is equal to, the term negative 2y comes down because nothing's happened to that yet, and then 22 plus negative 22, or 22 minus 22, is 0. I'll clean up my equation next by dropping that 0, so I have negative 12 is equal to negative 2y. Now on the side of the equation with the variable, the operation that's going on is multiplication. We undo multiplication with division, so I divide both sides by a negative 2. On the side of the equation with the variable, negative 2 and negative 2 cancels and leaves me with the variable y, and a negative 12 divided by a negative 2 is a positive 6. So my solution is y is equal to 6. And just going through the equation and what we've done, we first balanced the equation by taking 22 off of each side of the equation. We rewrote our equation, and then we balanced it again by dividing both sides by negative 2 to get our solution of y is equal to 6. This is the end of our video on solving two-step equations.